Okay, you guys with me? Okay, so we are going to start the second, can you all see me? Like the light is kind of weird. Anyway, we are going to start into the second half of the semester. And as I was telling you guys back several weeks ago, that once we get back from spring break, that we're going to dive into statistics. So one thing you guys need to do is you need to get on IBM SPSS, get on that website and download a free trial. The free trial is extended to 90 days. So you guys should be able to access that and have that for free. I'm going to be showing you guys, we're going to be working through some examples through SPSS. So that's where I think that perhaps more synchronous lecture here in a couple weeks might be useful, but we're going to take it one day at a time. Okay, so today to start our discussion about statistics, we're going to talk about descriptive statistics, and this is something that you guys, I hope, are familiar with. So I'm going to go through it a little quickly, and then I will be online during our normal class time on Friday, and we can talk about this if any of you guys have questions, and then I'll be holding office hours as well. Okay, so when we first start talking, let me move myself over here. So when we first start talking about descriptive statistics, one thing I want to point out is that descriptive statistics are just like when we were talking about descriptive methods, okay? So descriptive statistics are something that just describes. You can't make any conclusions based on it. So you are not able to draw anything from it other than just descriptive. So in this picture here on the slide, it shows that you perhaps pulled a sample and you were interested in the relationship status of those individuals in your sample, and you could see just how many of them were single versus married versus widowed, divorced, those sorts of things. So it does allow you to talk about your sample, talk about your data, just generally in basic format. So it's just describing. So you can't make any conclusions based on that. Okay, so first we're going to talk about measures of central tendency. These are all things that you guys should be familiar with. This is your friends, the mean, median, and mode. Just to remind you all, for those that might not remember, the median is the average of all of the data points. Take them all, add them together, divide by the number that they are, and then you will get an average of that information. The median is simply the middle score. If you line them up from smallest to largest, it's whatever score is in the middle, and then the mode is the most frequent value in your data set. So, and to be fair, what I'm about to talk about, we're going to spend a lot of time talking about the mean. Whenever we get into statistics, the mean becomes very important. So we are going to be dealing a lot with the mean. But that being said, the mean is not necessarily always your best descriptor for the data. So here in this data set, we see that we have 10 employees of this hypothetical company, and you can see that the salary of what people make, 15, 18, 16. And then you see these two here on the far right. You can see these, let's see, over here, where you have someone that is making 90,000 and someone making 95,000. We're going to assume that those are like the CEOs of the company, right? And so they are making a lot of money. So let's say that you're applying to a job at this company and you're trying to figure out just what the average salary is. You might look that up, and if you did that and you looked up the mean salary, it's going to tell you that the mean salary is about $31,000 a year. And so you might look at that and think, okay, that's fine. I just graduated college. I could survive on that. So that's going to be a good job. I'm going to apply to work there. But that number is a little misleading because, as you can see, the 90 and the 95,000 there are really pulling up that average. So it would be best to look at this data and maybe describe the median. The median would be, I think, 16,000. So that would be more descriptive. And also the mode in this particular data set would be 15,000. So that both of those measures are going to be more descriptive than that information here. So one thing to consider when you think about the mean as being the best measure, even though it is the one that we are the most familiar with, it's the one we use the most frequently, the mean is not always the best descriptor of the data. It is very sensitive to outliers. Another great example of the mean not being the best descriptor is when we think about life expectancy. Life expectancy, a long time ago, you've probably thought about this, about how life expectancy used to be, 35 or 40 or something like that. And you'd say, oh, well, ancient man only lived to be like 40 years old. Well, that's all great and wonderful, but honestly, a lot of people lived to about the same age that we're living now. A lot of people lived to be 60, 70, 80 years old. That was not uncommon. But the reason why that the average age, the life expectancy was so low back then is because infant mortality was so high. So whenever you take those measures of infant mortality and you have people dying of childhood, it was hard to make it to 5 years old a long time ago. So once you made it to 5 years old, you had your chances to live into your 60s was pretty good. So all of that data is not actually really descriptive of life expectancy. It was heavily influenced by infant mortality rates. So be aware of those types of things when you think about the mean. The other thing I want to say about measures of central tendency is when is the best reason to use these different measures. So again, we're going to be working a lot with the mean. Most of the dependent variables that we will be working with does use continuous data. So we will be looking at that information. So things on a scale, interval, ratio, sometimes even ordinal, depending on how your scale is, that's going to be your best use of the mean. For the median, the best use is whenever you have those outliers, because whenever you have those outliers, especially if you're unable to take care of them in a statistically legal way, then the median is going to be your best. It's going to be superior over the mean in those instances and a better descriptor. And then the mode is going to be best whenever you're looking at the categorical data. This little graph here, here on your right that says the number of colored Smarties in my box. If you had a pack of M&Ms, which we would have done a M&M lab, which is somewhat fun, and then you get to eat the M&Ms. But if you're looking at how many of each, say M&M, brown, red you have in your pack, that's going to be categorical or nominal data. And the mode is going to be the best descriptor whenever you're thinking about that data. Another example is just how many males versus females you had in your data set, or how many college age kids versus old age people, or something like that is going to be your best use of the mode. Okay, so that is your measures of central tendency. I will stop this here and then I will record a video shortly about measures of spread. Thank you all.